Hi folks, welcome back. Let's see, Physics 112. We're going to discuss problems 17 and 18 in your Unit 2, homework number 2 here. So 17 is about electrical energy costs, and there's a number given, this 0.12 dollars per kilowatt hour, right? That's an electrical cost type of thing a power company would, it's the rate at which a power company would charge you for your electrical usage. And let's see, it says to burn a 40-watt light bulb, for 24 hours. So part A, they give a wattage. Mine says 40 watts, and then it says for 24 hours. Yours has a different value here, but that doesn't matter. First of all, convert this to kilowatts. In this example, this would be 0.04 kilowatt. And then when you multiply by the number of hours, you get a number with units of kilowatt hour. And then you just use this like a unit conversion. That'll get you a cost. Part B is basically the same. They give a time, a current, 20 amps, and a voltage, 220 volts. Except, all right, the one difference is this. You have to calculate the power first. So remember, power is current times voltage. So you have a current, you have a voltage. The product of the two is a power in watts. Then convert to kilowatts. Then multiply by the number of hours given. You will then have a number with units of kilowatt hour. And then apply your cost per kilowatt hour. So that's pretty well all there is to 17. Let's see. 18, a portable coffee heater supplies a potential of 12 volts across a heating element that's 2.42 ohms. All right. So in number 18 here, you're given a voltage. Looks like that's the same for everyone, by the way. You're given a resistance. Now the resistance is red. I'm going to go ahead and put what I see, 2.42 ohms. Your number will be different because it's red. I'd probably start, no doubt, with Ohm's law. Voltage equals current times resistance. And you can now calculate a current. And you can also calculate a power from current times voltage. By the way, check it against I squared R. You should get the same value. Now this power will come out in watts. That's what they're looking for in part A. Let's see, part B. How many minutes will it take to heat up some coffee? So remember from physics 1, and I remember fall, we just kind of barely got to this, but all right, heat. Heat is energy transfer due to temperature changes. And the relationship between heat and temperature, they're related by what's called the specific heat. Specific heat, it's usually denoted with the letter C, is defined as heat over mass degrees centigrade. Really, it's the heat required to raise 1 kilogram by 1 degree centigrade. Equation-wise, Q equals mc delta T is something everybody should be familiar with since from first semester. This is an energy. This is a temperature change. So in this problem, they gave you a mass, they gave you a specific heat, they gave you temperature change. You should be able to calculate the heat. That is an energy. And then going back to the first part of this problem, when you calculate a power, remember that is change in E over change in T. So when you take a power times a time, it's an energy. Right? So you're going to take this, multiply by time, and you don't know the time, so just take your power times delta T is now an energy. This is an unknown, and set it equal to the energy calculated here. That should get you through that problem. I'm going to call that quits here and move on.